Hello everybody. So today I'm gonna solve some CTF challenge. So it's basically a simple buffer overflow. So here, so it asks us. So here you can see that Nana told me buffer overflow is a one of the, yes, it's been around like 40 years. So it's gonna be like our old vulnerabilities. So it asks us, first of all, it asks us for this binary file to download. Then here is our C file for buffer overflow. Then we need to connect to this network. So let's try that. Okay, let's paste it, then let's hit enter. Then it asks us that to type something. Yeah, definitely let's enter some integer. Then once we have downloaded that file, then what we can do is let's cat out our file. Then so our file name was bof.c. So this is our first file. So definitely it is asking us this overflow me. So here is our print file. Then so this part, then it went to this block, else block. So first of all, let's go through this source code. So first of all, there is a main function. So it uses argc argument c to argument, where this function is called and there is a value called deadbeef. So once it has been passed within a function, then it went inside a key value. So key value, and this value, this deadbeef is stored inside this key value. Then this function is opened, and there is a character which has 32 bytes. Then it asks us, then it prints us overflow me. Then after that it uses a get. So whenever you see a program using get, it's a buffer flow. So then we have this if condition. In this condition, it asks, it compares key value with cafe babe. So our initial goal would be to somehow manage this key value, which is dead beef. So we want this value to be as cafe babe. So how can we do that? So first of all, let's we just need a binary file. That's already we have it. So we can use dissembler. So we don't want fancy that kind of stuff, right? We just want simple dissembler. We can use obj dump. Then we can use -m for making intel syntax. So we can do intel, then -d for dissembler. Then our binary file name is bof. Then let's hit enter. Oh, that's my mistake. So what we can do is like simply grep do less pipe, then do less. So then we can thoroughly see our assembly code. So this all stuff is converted into this assembly code. So what am I trying to find? The question would be that. So I'm trying to find this main function assembly code. So right now we have this main function, main over here. So let me use pen for that. So our main is over here. So this is our function, this is our main function. So then we have to call a function inside a main function. So this is our main function, that stack pointer. Inside a stack pointer there is a value called deadbeef. So next we want to look at a function. So we don't need this, so we simply want to see the comparison where it has been done. So here is our comparison. So if we go a step back, then there is this function. So that function means this is a get function. Then we have our stack pointer is pushed. So if we go, this is the this EAX, inside EAX base pointer -0 to C is passed. So here we have 32. So if we use 32, then we can't overflow the stack. So our basic, so let me show you basic diagram for buffer overflow, how it is done. So here is our stack pointer, right? ESP SP. So I'm doing with mouse, so it might not be that good. So here is our stack pointer. Then we have our buffer space. So you can assume this is a buffer space. Then we have our EBP. So EBP okay, EBP. Then our EIP, instruction pointer. So whenever this, so we have overflow. So here our character overflow is here having this 2C value, that in hex it's like it's 44. Then we have EIP. After that we have that buffer space is there, buffer space. Then we have EBP. Then we need somewhere around here. Okay, now we want to make this is 4 bytes, and this is 44 bytes, and this is 4 byte. So what we simply did was, so our plan would be to fill up all this buffer space with A, that is 44. We are going to make this buffer space as 44A. Then our base pointer would be B4B. Then our instruction pointer would be 4C. Then we are going to get a flag. So this is the overview of what we are gonna do. So let me open my another terminal. Okay, here is my another terminal. So here what I can do is let's write our exploit, exploit. Let's see. So So in Python there is a library called pawn tool. So let's use I, and then from pawn import all. Next, context dot log underscore level equal to debug. This we are using a debugger mode. Then we need a connection. Let's write connection equal to our host name. So for that we need to use remote. Then let's use our host name. Host name is pawnable.kr with host, port number 9000. Let's close this bracket. Then next one would be to let's use p equal to, so we are going to pass a value that's to C, or we can do simply 44. You might be wondering how did I get that 44. So let me show you how I get that. So calculator, so it's right here, and here is our hex value. So if I try to calculate this, if I have this value, then let's use calculator. Let's paste it, and let's have equal to, okay, simply use. So here is our hex. In hex it is 44 bits. So that's how you get it. And next, okay, which one was it? Okay, this is the one, right? Then we can simply use, now we are at the buffer that has been filled with A. Next we want to fill B with 4. So next this B is being filled with base pointer. Then let's use P equal to C. So simply C is a instruction pointer that is also will be filled with 4. Then we need a actual value over here. So here we have key equal to, this is the value, right? So after using that much value, like 44, 52 bits space has been consumed by EBC. After that we are at this point that would be, so we want to pass the value. So definitely the little endian value B. So you might be wondering what am I writing. So I'm simply trying to match this string, then we will get our cell. So BA, then XFE, then XCA. That's what we need. So then we can write connection dot send line, then that would be P. So we are sending trying to get a connection. After that let's use connection dot interactive. then I think it's alright. So let's save it. Then let's try to run with Python. Okay, here I have written, okay, my mistake over here, cat. Then I can simply, I made, okay, this need to be on Python, right? Let's copy this, then let's use it, v, then python x.py. Here is our Python file. Let's save it. Then let's run with Python. Okay, then let's use autocomplete. Then let's run it. Let's wait. Okay. Oh, let's, okay, here my spelling is incorrect, remote. Then let's save it. I think it's all right. Okay, here we have got our shell. Then let's use ls. So here is our flag and our source code and all that. Let's use cat. Then let's use flag. Let's see our flag. So that's how you do the buffer overflow.